Alright, we're going to talk about how to do the metric system in a little different way to set us up for later on doing some different conversions like the mole. So some of you may already know how to do the metric system, and that's fine, but again, I'm trying to set you up so that you guys can do some things a little differently. So here's the stair step that I like to do, just to kind of give you an idea of how the metric system is set up. The key here is the base unit. The base unit is anything like liters, grams. Later on we'll talk about the mole, meters. That's your base unit. So anything that doesn't have a prefix, like our prefixes as you see is like giga, mega, kilo, hecto, deca, any of those. So as you go down this way, you are getting, it takes more of them to make the base unit. So if we want to write equivalency statements, those are like statements that equal one another. The key is the stair step kind of tells you things in the sense of like deci. So let's talk about like a liter, deciliter. And kind of your abbreviations. This is a little d, this is a little c, this is a little m. Micro is weird, it's a fancy U. Nano is N. Pico is P. Going up, deca you usually use a capital D. That's an H. That's a K. Mega is a capital M. And giga is a capital G. So there's all your abbreviations. So let's go back here and talk about deci for a minute. So you're below the base unit, so it takes more of the little decis to equal a base unit. So like if we talk about liter. So it's going to take so many decis to equal a base. So in this case, even 1, and that tells you the power of 10. So it takes 10 to the 1 deciliters to equal 1 liter, because you're below. The 2, 10 to the 2 centiliters to equal 1 liter. Milli, 10 to the 3rd milliliters to equal 1 liter. And again, you can write these out in the sense of 10 to the 3rd. What's 10 to the 3rd? Well, that's 10 times 10 times 10, or that's the same thing as 1,000. Those are the same things. Okay. And some of you will get to know that there's 1,000 milliliters in 1 liter. There's 100 centiliters in 1 liter. And that works for any of these. So you could say there's 10 decigrams in 1 gram. 100 centiliters in 1 liter. There's 1,000 milligrams in 1 gram. It works for all those. So that's going down. What about going up? It's the opposite. You put the number with the base unit. So 1 deca, we'll switch over to grams. 1 decagram equals 10 grams. 1 hectogram equals 10 to the 2nd grams. 1 kilogram equals 10 to the 3rd grams. Notice that the powers of 10 are going with the gram side because you're going up the stair step. So if you're going up the stair step, the power goes with the grams. If you're going down, it goes with the unit. Okay. Now, why are we doing it this way? Why are we setting these up this way? Okay, there's a reason. Okay, so let's use one of these that we talked about. Let's do like 10 to the 3rd milliliters equals 1 liter. Oh, sorry. Stop that. Okay, so that means 1,000 milliliters equals 1 liter. So let's say I gave you a problem and I said, all right, which some of you could do this without all this work, but it's for a purpose later. I promise you, what I'm doing now is for a purpose later. So don't take what I'm telling you how I want it done now and saying, oh, I know how to do it my way, forget her. No, do it my way. So if I ask you, how many liters is in, I don't know, 5 milliliters. Okay, so you'd say, okay, 5 milliliters, and I want you to do fractions, where you put milliliters on bottom, and you put then your liters on top, and then I want you to use this right here, 1 over 1,000, making, look, milliliters cancel, 5 divided by 1,000 is, I'm going to write it down here because I'm kind of out of room, 0.005 liters. And of course, we go back to the given, look at sig figs, there's 1, our answer is 1, and we have a nice label, liters. There you go. Okay, let's try another one. Let's give you the original problem now. Let's say I were to give you 650, not 650, 6.55 kilograms, or 65.5 kilograms, if I can talk now, and tell me how many milliliters that is. Okay, and again, some of you could do this, but I want you to start setting these problems up because there's a purpose for this later. First of all, it would help if I actually gave you a problem that made sense. How about milligrams? Okay, so you'd be like, this is actually a two-step problem, because you'd have, okay, well, I know if I go back to my chart that I looked at earlier, if you look at your stair step, you'd say, okay, well, kilograms to grams. Well, for every 1 kilogram, there's 10 to the third grams. And if you want to use exponents, you can, or if you want to make that 1,000, it's whatever you see. So you could say 10 to the third grams or 1,000 grams, whatever you see. And then you say, okay, well, that's grams though. So how many grams are in a milligram? Well, again, you'd say, okay, well, there's for every 1 gram, there's 1,000 milligrams. So you'd say, okay, 65.5, and again, you could say 10 to the third there too. 65.5 kilograms times, you'd say, okay, well, put what you're trying to get rid of on bottom. So my 10 to the third goes there, or 1,000, whatever you want to use. And my 1 goes there. And then my kilograms again goes on top. Oops. So now I want to get rid of grams. Grams goes there. And my milligrams goes on top. So if I go back there, 1, 10 to the third. Now look. So I have 1,000 and 1,000. So that's going to be a big number. 6, 5, 5 with 5 zeros. 1, 2, 3, 4, 5. And that's going to be milligrams. Okay. Hopefully that makes sense to you. If not, let me know. We'll do some more practice. We'll probably do some warm-up with this in class. Okay? All right. Again, I know there's probably an easier way to do this, but I want you to start practicing setting up these problems so that way you can do this later when we have some other things to do where you'll be like, oh, I get why we had to do this now.